Hello viewers, in today's session we are going to discuss some important problems related to Dirac delta function, right? So here we are going to discuss those problems which are based on the derivatives of Dirac delta function. So let us start. So let us first take this problem in which we have to evaluate this integral which is from minus infinity to infinity e raised to minus x square, and here we have the first derivative of Dirac delta function, that is delta prime of x minus 1, right? So in this lecture we'll see how we can find out the values of these kind of integrals which involves the derivatives of the delta function, right? So let us first see the property which we are going to use to solve these type of problems. So here's here we know that if we have an integral say from minus infinity to infinity, here we have a function f of x, and here we have the nth derivative of Dirac delta function, that is delta n x minus a dx. Then the value of this integral is given by minus 1 raised to n, and we have here the nth derivative of this function f of x evaluated at this point, that is a, right? So this is an important property of delta function, in which we have to find out the integral from minus infinity to infinity f of x, and here we have the nth derivative of the delta function, right? So n denotes the order of the derivative, order of derivative of delta function, right? So the value of this integral is given by minus 1 raised to n, and here we have the nth derivative of this function evaluated at this point, that is x is equal to a, right? So we'll use this property. So let us come to this problem. So here if we compare this integral with this one, then we see that our function f of x is e raised to minus x square, and here we have delta prime. It means the value of n is 1. So the first derivative of delta function is involved, and here x minus a, so here we have x minus 1, so the value of a is equal to 1. So now since n is equal to 1, so it means we have to find out the first derivative of f of x, right? Because here we have n is equal to 1. So f prime of x is given by the derivative of e raised to minus x square, and we have here e raised to minus x square, because the derivative of e raised to minus x square is e raised to minus x square, and then by chain rule we have to find the derivative of minus x square. So we have e raised to minus x square, and here we have minus 2x, right? So this is minus 2x e raised to minus x square. So the f prime of x is given by this expression. Now let us find out the value of this derivative at this point, that is a, which is f prime of 1. So we can substitute x is equal to 1 in this expression. So we have minus 2, then we have 1, then we have e raised to minus 1 square. So this is minus 2 times e raised to minus 1, that is minus 2 over e, right? So now the value of this integral, let us call this integral as I. So the value of this integral I can be written with the help of this expression. We have minus 1 raised to n. N is 1. So here we have 1. Then we have f prime of 1, right? So minus 1 raised to 1 is simply minus 1, and f prime of 1 is given by minus 2 over e. So here minus 1 multiplied with minus 2 is plus 2, and it is divided by e, right? So the value of this integral is given by 2 over e, where e is the exponential number, right? And here remember, e raised to minus x square is a Gaussian function. So now let us take this second problem. So here we have the integral minus infinity to infinity, the natural log of x plus 1. And here we have the second derivative of delta function, that is delta double prime x dx, right? So now see, we can rewrite this integral as minus infinity to infinity log of x plus 1. Then we have delta prime of x minus 0, right? So here this x can be written as x minus 0. And now if we compare this integral with this one, then our function f of x is given by a log of x plus 1. And here the order of derivative is n, and n is given by 2, right? And the value of a, that is the point where we have to evaluate the delta function, or the delta function takes the value, is a is equal to 0, right? So a is 0. So now here we have n is equal to 2. It means we have to find out the second derivative of this function f of x, because here we have the nth derivative of f at a. So we have to find the second derivative of f of x. So f prime of x is given by d by dx of log of x plus 1, right? So we have the derivative 1 over x plus 1, and by chain rule we have the derivative of x plus 1. So this is 1 over x plus 1, and here the derivative of x with respect to x is 1. The derivative of 1 being a constant, it is 0. So we have simply 1 over x plus 1, which can be written as x plus 1 raised to minus 1, right? Okay, so now let us find out the second derivative. So f double prime of x is given by d by dx of this function x plus 1 raised to minus 1. So we have minus 1, then we have x plus 1 raised to minus 2 by the nth power law. And here we have the derivative of x as 1 and derivative of 1 as 0. So this is minus 1 over x plus 1 square, right? So the second derivative of f of x is given by this expression. Now we have to find the value of the second derivative of f at this point, that is a, which is f double prime. A is 0, so we have minus 1 over 0 plus 1 square, because we have to take x is equal to 0 in this expression. So we have minus 1 over 1 square, that is equal to minus 1, right? So now the integral I can be written with the help of this result. So we have minus 1 raised to n. Here we have minus 1 raised to 2, because n is 2. Then we have f double prime of a, that is 0, right? We can also use the notation f, and here we can write 2, and this is 0, right? So minus 1 square is simply plus 1, and f double prime of 0 is given by minus 1, right? So the product of these two numbers is simply minus 1. So the value of this integral is given by minus 1. Now let us consider this third problem. So here we have the integral minus infinity to infinity x sine x and delta double prime x minus pi by 2 dx, right? So here we have to evaluate this integral with the help of this result. So if we compare these two integrals, we can easily conclude that our function f of x is given by x sine x, right? So here the function f of x is the product of x and sine x, and here the second derivative of delta function is involved. So the value of n is given by 2, right? So second order derivative is involved, and the value of a is given by pi by 2, right? So now let us find out the second derivative of this function, because here we have n is equal to 2. So it means we have to find the second derivative of f of x at this point a, which is pi by 2. So f prime of x is given by d by dx of x sine x, right? So here we'll make use of the product rule for differentiation. So we can use this result, that is d by dx of u times v, where we have two functions u and v, which are functions of x. So we have u, then we have dv over dx, then we have v and du over dx. So here we can take u as x and v as sine x. So we have x, then derivative of sine x, then we have sine x and derivative of x. So this is x times cosine x, the derivative of sine x is cos x, and here we have simply sine x because the derivative of x is 1, right? So let us find out the second derivative. So the second derivative is given by d by dx of x cos x plus sine x, right? So here we can find out the derivative of x cos x by using this result. So we have x derivative of cos x, then cos x and derivative of x, and then we have the derivative of sine x. So here we have x, derivative of cos x is minus sine x, then we have cos x, derivative of x with respect to x is 1, and the derivative of sine x is cos x. So now we have minus x sine x, and cos x plus cos x is 2 times cos x, right? Okay, so now we have to find the value of the second derivative at this point. So f double prime of a is given by f double prime of pi by 2. So we have minus pi by 2, taking x is equal to pi by 2. Here we have sine pi by 2 plus 2 times cos pi by 2. So here we have minus pi by 2. Sine pi by 2 is 1 because sine 90 degrees is 1, and then cos pi by 2 is 0. So this is simply minus pi by 2, right? Minus pi by 2 times 1 is minus pi by 2, and this term disappears here. So we have minus pi by 2. So now this integral I can be written with the help of this result as minus 1 raised to 2, because we have the second derivative, and then we have f double prime of pi by 2. So now minus 1 square is simply plus 1, and f double prime of pi by 2 is given by minus pi by 2. So this is 1 times minus pi by 2 is minus pi by 2. So viewers, the value of this integral is given by minus pi by 2. So now let us consider this problem. So here we have minus infinity to infinity, and we have x times the second derivative of delta function x plus 1 dx, right? So here we have to evaluate this integral with the help of this result, right? So let us compare this integral with this one. So our f of x is given by as x, right? And here the second derivative is involved, so the value of n is 2, and here we have x plus 1, right? And here we have x minus 1. So x plus 1 can be written as x minus minus 1. So our a is equal to minus 1, right? Okay, so now see, the value of this integral I is given by this expression. So we have minus 1 raised to 2 because the value of n is 2, and then we have f double prime of a. So a is our minus 1, right? So minus 1 square is simply plus 1, and here we have f double prime evaluated at minus 1. So 1 times this number is given by f double prime minus 1, right? So now we have to find the value of this expression. So here we have f of x. So the first derivative is given by d by dx of x. So the derivative of x with respect to x is 1, and the second derivative is given by d by dx of 1, right? Because here we have 1, and this is a constant, and we know that the derivative of a constant is 0, right? So the value of the second derivative f double prime of x at this point, that is minus 1, is simply given by 0 because this term is independent of x, right? So we have the second derivative at minus 1 is equal to 0. So here we have simply 0, right? So the value of this integral I is equal to 0. So viewers, this is how by making use of this important property of Dirac delta function, we can evaluate these type of integrals.